I should always give the scientist caveat that this is not supposed to suggest that alligators get influenza. This is supposed to illustrate the concept of evolution, where we here have, the primitive animal climbing out of the primordial slough and moving forward and, progressing to the human. So it's a standard diagram of evolution, and that's also what influenza does. But influenza itself moves from one species to another a lot. Every time influenza moves from one of those species to another, it's having to evolve. I've been studying the evolution of resistance to Tamiflu in influenza. And when Tamiflu was first developed, they tested to see, was it likely that influenza would become resistant? And the answer that people came up with at that point is no, influenza would not become resistant to Tamiflu, because it was really hard for the virus to do that. One thing about viruses is they tend to always surprise us. So 2007, 2008, one of the strains in influenza in humans all of a sudden started to become widely resistant to Tamiflu. A question I was interested in is, why did that happen? What enabled that to happen? So many of the most important infectious diseases, not only influenza, but things like hepatitis C and HIV, are really evolutionary diseases. The reason we haven't been able to cure them is because they're evolving faster than we can respond. So we're going to have to somehow understand where they're going to go or get a step ahead of them. My hope and my goal is to predict evolution, but realistically, I think that if we can predict some of sort of the currents of evolution and the obstacles and forces that are driving those currents, that'll be a huge success, both from a scientific perspective, but also from a kind of health perspective.